Okay, so now that we know what we want to count, where do you want to start?
Well, we could start just with maybe we could try to use choosing numbers on this, since that's the section.
Ah, good idea. We're gonna try. We should probably use choosing numbers.
But what are we?
How can we use the choosing numbers?
Trying to choose the number of three of a kind.
Yeah. So it's probably going to involve choosing numbers somehow, but we don't need to get super caught up in choosing numbers. What are the things we need to count here?
Well, we need to count how many ways there are for three cards of one type to show up.
Okay.
And then we also need to figure out what's the probability that, how many ways are there for these to be different.
Ah, okay. So that's great thinking. We have several things we got to figure out.
Yeah.
The set of 3. We should investigate that.
And then the set of 2.
And then we need this set of 2, and this set of 2 has to be different.
From the set of 3.
Has to be different from the set of 3.
And from each other.
And from each other. Ah, very interesting. Okay, so what seems like a good thing to look at first?
The set of 3.
All right, may as well look at the set of 3 first, because it's hard to look at the set of 2 first, because then you're saying I need it to be different from something I haven't looked at yet.
Mm-hmm.
Okay, so the set of 3. What can we say about that set of 3?
Well, we have, I think there's 13 different cards that you can put in each place.
Aha.
Like you can have a 3 of a kind of, you can have a 3 of a kind of aces through kings.
Okay.
Or 2s through aces, whichever one
I
we're
see
playing.
something.
All right.
If order matters, then will this different?
Very good question.
I think, well, that's the same 3 of a kind. They're the same 3 cards.
Absolutely right. That is the same 3 of a kind. So in this particular thing we're counting, order does not matter. But that's a super important thing to notice.
Yeah.
Okay. So you've noticed that there's 13 suits. Sorry, 13, not suits, 13 cards, types of cards we can put in from ace 2, 3, 4, all the way up to jack, king, queen.
And
Okay.
And then there's 4 of each type of card.
Ah, there's 4 of each type of card, so maybe I better bring out the last king here. Didn't I already bring that out? Where did I put it? Here it is.
diamond king.
Okay. Once I choose the 13, so I choose one of the 13. In this case, we chose
Kings.
kings. What do we have to do now?
Now we have to figure out how many arrangements do we have of these kings that are all different.
Okay. We're not done yet once we figure out which one of the cards we're using. Because why?
We have to figure out the arrangements.
Okay, so what does that involve?
Well, we need to figure out, so we have four kings and we have to choose 3 of them.
What does that remind you of?
Counting numbers.
What kind of numbers?
Choosing numbers.
Choosing numbers.
Choosing numbers. Okay.
So we have 4 kings, then choose 3.
Okay.
And that's, well, it's 4 factorial of 3. That's going to be 4 ways you can do it.
Aha. There's 4 ways to do it.
Which, it's 52 ways.
That's true. There's 52 ways.
But then we
total.
have to count these.
Yeah, let's not jump ahead though. Let's see, is there an easy way to understand why there's 4 ways to choose a set of 3
Well,
out of these 4?
because you have this set, then you can remove the club king,
You can remove
the spade king,
and the
or you
heart
can remove
king.
the heart king.
Aha. See, removing 1 card leaves you with a set
And
of
then
3.
remove the diamond king.
Yeah. So picking a set of 3 is the same as picking
So, removing 1.
a single card. So picking a set of 3 is the same as picking a set of 1. So there you go. So we found how many ways there are to make a set of 3.
Yeah.
13 times 4. Now we have to move on
52.
to over here. Okay, you
Okay.
ready for that?
Yeah.